You are probably using tools like ChatGPT, Claude, Gemini, or maybe even Microsoft Copilot daily at this point.
Oh, absolutely. Everyone is.
Right. I mean, you type in a question, you hit enter, and paragraphs of just highly structured, seemingly intelligent text appear on your screen.
Yeah.
And you already know it is not magic, but there is this massive gap between knowing it is software and actually understanding the mechanics happening under the hood.
Well, the disconnect between our reliance on this technology and our understanding of it it's just fascinating.
It really is.
We all know how to press the accelerator to make a car move, but asking the average driver to explain, like, fuel injection or how a transmission shifts gears usually results in a blank stare.
Yeah, I give you a blank stare for sure.
Right, and it's the same here. We interact with the surface layer of artificial intelligence, but the actual mechanical reality remains completely hidden away in these massive data centers.
So that hidden mechanical layer is exactly what we are going after today. Welcome to this deep dive. Our mission today is to unpack our source material, which is some incredibly detailed notes from episode 3 of the EdTech Learning Series.
Very detailed.
Yeah, and we're going to use them to completely demystify the core technology powering this current AI revolution. We are talking about large language models, or LLMs.
Which is really the foundational architecture of the modern web right now.
Yeah.
And people often treat these systems like a mysterious black box, And that leads to a lot of misplaced trust and, on the flip side, a lot of unnecessary fear.
Totally.
By breaking down the components of that box, you move from being a passive consumer of the technology to an active, intentional director of it.
Okay, let's unpack this. We throw around the acronym LLM constantly, large language model.
Right.
But before we can understand how to use these tools better, we really have to strip away the intimidating terminology and define what an LLM actually is. So let's start with the middle word, language. On the surface, that just means it deals with words and sentences and conversations instead of, analyzing satellite imagery.
Right, it works with text.
But it doesn't actually read English the way you or I do, does it?
No, it does not read English at all. It reads math.
Math.
Yeah. To a computer, a word like apple has no intrinsic meaning. There's no flavor, no color. So the very first thing the system has to do is translate human language into a format a machine can process.
Okay, how does it do that?
It uses a system called tokenization. So it basically takes every word in its data set and chops it up into smaller pieces, or tokens, and then assigns a unique number to each piece.
Oh, I see. So a short word might be one token, but a longer word gets sliced up into syllables.
Exactly. So the word hamburger might be broken up.
That's wild.
Yeah. And once everything is converted into numbers, the system can start plotting those numbers on a massive, multidimensional mathematical map. And this is where we get into the concept of a model.
So the model is the map itself. It's not just a giant digital filing cabinet where it stores every book it has ever read.
No, and honestly, the filing cabinet analogy is probably the most common misconception out there.
People definitely think that.
They do. People assume the AI has a hidden hard drive containing the entire Wikipedia database, and it is just running a rapid search query.
Right.
What it is actually doing is modeling the relationships between those tokens. On that massive mathematical map, tokens that appear near each other frequently in human writing are placed closer together.
Like related concepts.
Exactly. It learns that the token for doctor often appears near the token for hospital. It learns the structural rules of grammar, where nouns and verbs typically sit in relation to one another.
Wow. So it is mapping the architecture of human thought just by looking at the proximity of words in trillions of documents.
Trillions of words. Yes.
Trillions.
And that brings us to the large part of large language model. We are talking about a scale of ingestion that is honestly difficult for the human brain to comprehend. It reads millions of books, websites, manuals, and research papers. It's like a person who has spent years just absorbing all of human communication. To map the relationships between all those trillions of tokens, the system uses what are called parameters.
Wait, does large mean the physical size of the supercomputers running this? Like, I always picture those giant warehouse data centers with rows and rows of blinking servers.
Well, what's fascinating here is that while the physical infrastructure is massive in this specific context, large actually refers to the sheer volume of data, those trillions of words and those parameters.
Okay, parameters.
Yeah, you can think of a parameter as a weighted connection or, say, a mathematical dial. Modern LLMs contain billions or even hundreds of billions of these dials inside the AI's brain.
Hundreds of billions.
Yeah, so every time the system reads a sentence during its training phase, it slightly adjusts millions of these dials to better reflect how those specific words relate to each other.
Okay, so it is not large like a building. It is large like the neural network of a brain. It is a dense web of weighted connections.
Precisely. It is a statistical representation of language.
Mhm.
And because it has hundreds of billions of these parameters, it can capture incredibly subtle nuances.
Give me an example.
Well, it doesn't just learn that bank is a place for money. It learns that if the word river is nearby, the dial should adjust. So that bank now means the edge of the water.
Okay, that makes perfect sense, and it leads directly into a massive point of confusion the EdTech sources bring up.
Oh, definitely.
Because now that we know what an LLM is, we have to correct this massive misconception. People say, oh, I used ChatGPT to write this report, and they fundamentally believe ChatGPT is the large language model.
Right.
But based on what we just discussed, this massive web of mathematical parameters, that is just not true.
No, it's not. We tend to conflate the interface we are clicking on with the technology powering it. You interact with the software wrapper, not the underlying math.
Right, and the source material uses a really effective mechanical analogy here.
The engine analogy, yeah.
Exactly. The LLM is the engine. ChatGPT, Gemini, Claude, those are the cars built around that engine.
Yeah.
They use the LLM to understand the question and generate the response.
Exactly. The car is the dashboard, the steering wheel, the user interface.
Yeah.
It's the part that remembers your past conversations, gives you a nice clean text box, and adds system-level instructions behind the scenes to make the AI polite.
But underneath the hood.
Underneath, those consumer applications are sending your text down into the raw LLM to actually process the request.
So it's like saying, I drove a V8 today when you actually drove a Mustang.
Yes.
The V8 is what makes it go. It's doing the heavy lifting. But the Mustang is the steering wheel, the seats, and the interface you actually interact with. You don't interact directly with the pistons of a V8, just like you don't interact directly with the billions of parameters of an LLM.
That framing is perfect, and it explains why the AI landscape looks the way it does right now.
How so?
Well, you might see 5 different software companies offering different AI assistants that all feel somewhat similar. They built different cars, right?
Right.
Maybe one is a luxury sedan designed for legal professionals, and another is a sports car designed for writing code. But they could all be licensing the exact same V8 engine from a central provider to put under their hoods.
Okay, so we know it's an engine mapping tokens, and we know we are just sitting in the driver's seat interacting with the dashboard. Let's actually pop the hood.
Let's do it.
When you put your hands on the steering wheel and ask this engine to do a task, what mechanical process actually happens?
So let's pull a practical example from the EdTech notes. Imagine you sit down at your interface of choice and type. Can you write a professional email asking for a meeting?
A super common request.
Yeah.
Probably happening millions of times a day.
Right. What the LLM does not do is go searching through a hidden directory of pre-written emails looking for a match.
Because it doesn't have a hard drive full of files.
Exactly. It generates the response sequentially, one single token at a time.
One token at a time.
Yes. It looks at the prompt you provided, converts your words into numbers, runs those numbers through its hundreds of billions of dials, and calculates the mathematical probability of what the most logical starting word should be.
Wow.
It writes that first word, and then it pauses.
It calculates the first word, writes it, and stops.
Yep. Then it looks at your original prompt, plus the new word it just wrote, and runs the entire calculation again to find the most probable second word.
And it just keeps doing that.
Over and over, word by word, until it reaches a special token that tells it to stop. And this is exactly why, if you ask the exact same question twice, you'll get a slightly different answer each time.
Hold on, so it's basically just a highly advanced version of the autocomplete on my phone's keyboard. It's just guessing.
At its most fundamental mathematical core, yes, it is predicting the next item in a sequence.
That's crazy.
But comparing an LLM to a phone keyboard is like comparing a bicycle to a space shuttle. Because it has hundreds of billions of parameters, its guesses are capable of summarizing 20-page reports or translating emails into French.
Or brainstorming 10 creative team-building ideas.
Exactly. It uses a breakthrough architecture called the transformer, specifically the attention mechanism. It looks at the entire context of your prompt all at once, mathematically weighing the importance of every word against every other word.
It holds that vast web of context simultaneously, so its guesses are just highly, highly sophisticated.
Very sophisticated.
Here's where it gets really interesting, though. If the system is fundamentally just predicting the next word based on statistical patterns, what happens when it predicts wrong?
That is the big question.
Because this mechanical reality perfectly explains the AI's most famous flaw.
Yes, because it is predicting language. An LLM does not know facts the way human beings do. It is strictly predicting language.
It possesses a language model, not a world model.
Exactly. A human knows that Paris is the capital of France because they have learned a fact about the physical world.
Right.
An LLM outputs that phrase because the tokens for Paris, capital, and France are tightly clustered on its mathematical map. It is a statistical association.
Most of the time, those predictions are highly accurate, but sometimes they just aren't.
And when the AI makes a mistake or invents information entirely while sounding incredibly confident, this is called an AI hallucination.
Right. So what does this all mean for us as users? If it can confidently lie to me, how can I trust it to write code or explain complex concepts?
Well, this is why critical thinking is absolutely essential. Verification is mandatory. You have to treat the LLM as a highly capable, extremely fast, but occasionally sloppy assistant.
Trust but verify.
Always. Which leads us directly to the art of prompting. Because the AI is predicting words and doesn't inherently know facts, the way you speak to it, the way you steer the car, dictates the quality of the prediction.
Okay, so the EdTech notes highlight this dynamic beautifully. If you give the AI a generic prompt, like just write an email, you are giving the engine almost no context.
Right, you're leaving the probability space wide open. The model has to guess who the email is for, what the tone should be. You'll get a generic, unhelpful prediction.
But if you use a highly specific prompt, so the example from the notes is, write a friendly email to my manager asking to move tomorrow's meeting from 2 p.m. to 3 p.m. because I have a dentist appointment.
Now you're giving the engine exact parameters to work within.
You've narrowed that probability space.
Drastically. By defining the tone, the recipient, the specific time change, and the specific reason, the dentist appointment, you force the attention mechanism to focus only on the tokens relevant to those constraints.
So better instructions equal better results. It really sounds like giving instructions to an eager but overly literal intern.
That is exactly what it's like.
You can't just walk up to an intern's desk and say, do work. You have
Yeah.
to give them the who, what, when, and why.
Exactly. The engine needs tight guardrails to predict the perfect sequence of words.
Once you master the prompt and understand the engine, you start to realize this exact same technology can be applied to almost any industry.
It's incredibly versatile because language is the foundation of almost every business process.
The exact same LLM can power a customer service bot, a tool for summarizing legal documents, or like a virtual tutor for students.
Yeah, the EdTech source uses a brilliant final analogy for this.
Oh, the writer analogy.
Right. Imagine hiring the smartest writer you've ever met. They've read everything, they speak dozens of languages, they can explain science to a child, or write a CEO's business proposal.
That writer is the underlying LLM.
Exactly. And one day you sit them at a desk and they are a travel planner. The next day you move them to a different desk and they are writing software.
It's the same person, or rather the same LLM, but in a different role.
Same engine, different application.
I love that.
Yeah.
There is such a joy of discovery here. It is so empowering to realize that by learning to talk to one tool, you are essentially learning to communicate with the foundation of all future software.
You're learning the operational language of the next decade of technology.
Okay, let's do a rapid-fire recap of everything we just covered. We unpacked the LLM, the large language model. We discovered it's the engine, not the car. We learned it works by predicting language one single word at a time based on vector probabilities. We realized why a lack of a world model leads to hallucinations.
Very important point.
And finally, we realized why a dentist appointment is the perfect example of why detailed prompts matter.
If we connect this to the bigger picture, understanding this engine makes you a more powerful, critical, and efficient user of AI.
Definitely.
When you know it predicts words, you protect yourself from hallucinations. When you write better prompts, you save time. You stop treating the interface like magic, and you start utilizing the engine.
It takes the fear out of it. It's just an engine.
It is just an engine. But I want to leave you with one final thought today, something that builds on everything we've discussed.
Okay, let's hear it.
These models became large by reading trillions of words written by humans. Human text was the fuel. But today, the internet is being flooded with text generated by these very LLMs.
Oh, wow.
When the next generation of LLMs has to learn by reading text created by artificial intelligence instead of human beings, what happens to the engine then?
That's a scary thought.
Will it get smarter? Or will it slowly lose its human touch?
An engine running on its own exhaust. Well, that is definitely something to chew on. Thank you for joining us on this deep dive into the mechanics of large language models.
It was a pleasure.
Keep asking questions, and we will see you back here for the next one.